Mathbusters!
Hi Kelly, I'm so glad you've come to tutoring today. So we're covering sections 6.4, 6.5, and 6.6. So we're learning about parallelograms, and here's some shapes that we should be covering. So this is a rectangle. A rectangle is a quadrilateral, which means it has 4 sides, and it has 4 right angles, and its diagonals are congruent. So this is what that looks like, and then 4 ticks. Okay, our next shape is a rhombus. It's a special quadrilateral. It has 4 congruent sides, and it has perpendicular bisectors. So these make right angles. And then each diagonal bisects a pair of opposite angles. So these diagonals on this angle right here and this angle right here, and that angle, these two are congruent, these two angles are congruent, these two angles are congruent, and these two angles are congruent. So, and then a square, it's like the baby of all the shapes. It's like they all had a baby. And then, so it has all the same properties as like a parallelogram, a rectangle, and a rhombus. And so it has 4 congruent sides, so 4 tick marks. And then it has 4 right angles. And as you can see, just like the rectangle, it has 4 right angles, and just like the rhombus, it has 4 congruent sides. And then we have a kite, and it has 2 pairs of congruent consecutive sides, which means 2 sides that are right next to each other. So these 2 sides are congruent, and then these 2 sides are congruent. And also it has 1 pair of opposite sides, and they're congruent. So these 2 sides are congruent. And then its diagonals are perpendicular, just like the rhombus. So let me redo that shape. So it makes a right angle. So do you got that, Kelly? So now we're going to be going in depth about trapezoids. So a trapezoid is a quadrilateral, just like all the other shapes, and it has 1 pair of parallel sides, and its parallel sides are the bases. And the bases are the parallel sides, the legs are the other sides, and they intersect, and they're not parallel. Well, they'll eventually intersect. And then you have the base angles, which are the consecutive angles whose common side is a base. So this angle and this angle are consecutive angles, and their common side, so this is their common side right here, it's the base side, and same for at the top. And then isosceles trapezoid. An isosceles trapezoid is basically what this picture is here. Its legs are congruent, and its bases are parallel, and its legs are not parallel. And when you make the bisectors, they are congruent bisectors. And yeah, and then we have the mid-segment of a trapezoid, and that means, so if I erase all the mid-segment goes from here to here, and the mid-segment is a segment and its endpoints mark mid-segment of the legs. So this side and this side are congruent, and this side and this side are congruent. So you got that, Kelly? Kelly, I have a problem for you to do. Kelly? Kelly? Math. 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 Oh my gosh. Math. Let's solve a square. Let's solve a kite. Let's solve a rhombus. Let's solve these problems. Math. Math. Oh my gosh. Math. Math. These angles equal 360. These angles equal 360. These angles equal 360. These interior angles equal 360. Math. 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 Oh my gosh, math. These problems rule. These problems rock. These problems rule. These problems rock my socks. Kites have perpendicular bisectors. Squares have 4 congruent sides.
Yeah.
Rectangles have 4 right angles.
Totally.
Rhombus has 2 parallel sides. Period 4. Period 4. We're so awesome. Let's party.
He's right there, Dakota.
Kelly. Kelly. Kelly, wake up. Wake up!
What?
Do you know how to do the problem now? Alright, Kelly, here's a problem.
I can do this. See, this is congruent to this. And this is congruent to this. So then, if EB is 3 and EA is 4, then we can use Pythagorean's theorem because it's a right triangle. So it's 3 squared plus 4 squared equals C squared. So 9 plus 16 equals C squared. Then that's 25. And what's the square root of 25? It's 5. So A, B equals 5.
Good job, Kelly.
Thank you.
How about this one, Kelly?
I wasn't really ready to explain it.
How about this one, Kelly?
I can do this. See, AC equals BD. So AC equals BD. And it says right here, AF is 22.5. But then the whole BD equals 40. So then it's to find out this one right here, you can just do 22.5 minus 40 equals negative 17.5, but then I put that in front of that, so actually it's just regular. 17.5 equals FC.
You're doing so great, Kelly. Here's the next problem.
I can do this. Okay. It says DB, line DB, is congruent to AC. So, and that's given right here. So that's just given. Then it says reflexive property of congruency. Well, what reflects? It can either be this or this, whichever you choose. I'm just going to write AC is congruent to AC, line AC. And then next it says triangle DAC. So DAC. Oops, I just erased it. DAC is congruent to CBD right here. So that equals SAS because we know this is congruent to this and we know this line is congruent to this line. So also we know that this angle is congruent to this angle. So that equals SAS. Next it is, F5. Angle ADC is congruent to blank. Well, what angle is ADC congruent to? BCD. Right. BCD. And what's that? It's a right angles theorem. Okay. 6. DAC and angle BDC equals supplementary, which means they are supplementary. So that means they have corresponding angles, because DAC, angle DAC, which is this angle right here, and BDC, just this angle right here, they're corresponding. Okay, number 7. It states that congruent angles are supplementary and are right angles. So, what are the right angles and that are supplementary? They are angle A, angle B, angle C, and angle D, equaling 90 degrees each. So each of them are right angles. Then ABCD is a rectangle. How do you know that? Parallelograms with right angles with one right angle. One right angle equals a rectangle.
Good job, Kelly. This is our last problem of the day.
Thank God. Okay, so the measure of angle DAF equals 3y, and the measure of angle BFC equals 90 degrees. So BFC right here is 90 degrees, and angle DAF equals 3y, so 3y. And then, so this equals 6y plus 6 equals 90. So y equals 14. Then we are finding BAF, so measure of BAF equals 3 times 14, which then equals 42 degrees.
What's wrong, Jack?
Matthew, I've got this problem for geometry. It's my like homework. It's a really big grade. She gave us this parallelogram, this rhombus, and she wants us to make smaller ones, but she wants the angles to be the same and them to be all similar. And so I've just been cutting them out, and it's like not working. I just don't get it. They look terrible.
Oh,
Can you help me? Like,
Well,
what do
I'm
I need?
a certified math buster here. So I have this rhombus here, and as you can see, each side of the opposite sides, they're parallel. So you could start there. Also, they're bisectors. These are congruent and these are congruent because they're separated by the midpoint by the other bisector. And then these angles, because of these bisectors, they make it the two angles congruent. So these two angles are congruent, these two angles are congruent, these two angles are congruent, and these two angles are congruent. So, and then also in rhombuses, all the sides are congruent. So there's all the information you need to solve the problem. Do you get it?
Yeah, I get it now. Thanks, Matthew.
Now you are a math buster.
Yay!
Let's have a party.
Let's have a math buster party. Yeah, get rid of that ugly thing.
Okay.
And this ugly thing. Yeah, let's dance, Matthew. Yeah.
Math buster.
Yeah, math
Got
busters.
this.
Now turn it off. Turn it off.
1, 2, 1, 2, ready, go. When you need some help with your geometry, who you gonna call?
Math Busters!
Math Busters.
Oh.
Wait, why does it keep doing that? Oh, wait, hold on.
As you get over there.
No, we're gonna do a funny cut.
Alright, you gotta do a funny pose like as soon as you get there then. It's recording. It's recording. It's frickin' recording. Come on. Come on. You got this. It's a party. Party. Hey, language.
Kelly. Kelly. Kelly, wake up. Kelly.
That's not my face.
Bloopers. Dance, Kelly.
Hit it.
1, 2, 1, 2, ready, go. When you need some help.
Geometry.
Okay, again. Are we
Who
clapping?
are you
or
gonna
snapping?
call? Math.
Are we clapping or snapping?
Are we clapping or? Kelly, go.
No.
Do something.
No, not now.